If the data is there in the linked list, we are unable to access. That's why the head pointer is very important. We have to traverse the linked list till the end node. Once we reach the end node, we have to make the previous node next element as null. When we delete the nodes, it is not freed. The data will be present, but it is not accessible. That condition is called as garbage. Hello everyone, welcome to the session on data structure using C for second semester B.Ca student. Myself Intu J, Faculty of Computer Science Department, Vidhyaashram First Aid College, the Temple of Excellence, MYSURU. In this session, we are going to continue the discussion on Unit 3. That is linked list. In previous session, we have already discussed what is linked list, how many types of linked list there are there, how to create the node and what are the operations on the linked list. And also we have discussed the C code for traversing a linked list and to insert operation. In today's session, we are going to discuss about the delete operation and then the searching, how we are providing a searching in the linked list. Let us start the session. How to delete the node in the linked list. As we have done in the insertion at the 3 different places, deletion also can be done in the 3 different places. One is at the beginning of the node linked list, at the end of the linked list, and at the particular position. So deletion can be done at the 3 particular positions. So let us see how to delete a node from the linked list at the beginning of the linked list. So what we are going to delete, what we have to do in that, point the head to the second node. As I've told you, the head pointer is very important. Why it is very important? Because if we lose that head pointer, the address stored in the head pointer, we won't get to know where the linked list starts from. If the data is there in the linked list, we are unable to access. That's why the head pointer is very important. So point the head pointer to the next node. So if this is my linked list, we are having some 3 nodes. This is my head, right? So first node of the linked list will be always the head node. First, what we have to do, make this head pointer to point to the second node of the linked list. First, after doing this, after changing the head pointer, then we have to delete this particular first node. That is what the procedure we are supposed to follow. You know how to create the node using the structure we are creating the node, right? So we have used a type structure of to create the variable to delete. This is a pointer which is used to delete. Pointer is of what type? Pointer is of structure type. First, what we have to check, to delete anything in the linked list, we have to check whether there are the elements in the linked list or not. So how we are going to check that? If head is not equal to null. If some values are there in the head, then we can say that there are the elements in the linked list, right? So that's why we are checking the condition if head is not equal to null. If it is not equal to null, definitely it implies that there are some elements. If some element is there, then we can go for the delete operation. What exactly we are doing for this variable to delete, what we are giving? We are giving the value of head. If the value of head is say 1000, that 1000 is given to the variable to delete. After assigning this value to the variable delete, what we have to do? We have to point this head to the second node. How we are pointing it? By making head is equal to head of next. What? Which is a head of next? This is a head of next. Say some 2000 values there. That 2000 value will be given to as the head value. Right, now we are making it point to the second node of the linked list. After doing so, what we have to do? We have to delete this particular first node. How we are deleting? Using the free function, that is a dynamic memory allocation function, free function. For what I am freeing? I am freeing this particular variable. What is stored in that variable? The value of the first node is stored in that variable. So once we are deleting, we are calling the function free with the variable to delete, and after this what we have to say, we have to make that particular pointer as null. If not, pointer will be holding the same value 1000. So make it that pointer as null. So this is a procedure how we are deleting the element or the node from the linked list at the beginning of the linked list. Next, moving at the end of the linked list, how we are going to delete a element or the node from the end of the linked list. What is the procedure we have to follow? The same procedure, we have to traverse till the end node. We have to traverse the linked list till the end node. Once we reach the end node, we have to make the previous node next element as null. Previous node next field as null. That's what we are doing. Traverse to the second last element and change its next pointer to the null. So as we have a linked list here, so there are 3 elements in the linked list or 3 nodes in the linked list. So this is obviously the head node. Right, we have to traverse last but one node where this is a null right now for me, right, because this is the last element. So the next point of this node will be null. So instead of this, we have to make this previous node next field should be null. Once we have done this, we should delete or we should free this particular node. Yes, that's what we are going to do. Struct node, we have already know we are using one variable called temporary variable. Why this temporary variable will be used to traverse? Why this temporary variable is used to traverse from one node to the another node? And one more variable, that is to delete. Which node supposed to be deleted? The address will be stored in that particular node variable. Then what we are checking with the condition? We are checking with the condition temp of next of next. What is temp of next? Now this is a temp. What is temp of next? Temp of next will be the address of this node, and temp of next will be the address of this node. If this node is not equal to null, what we have to do? We have to increment the temp pointer. Okay, but in this case, it is equal to null. So what we are doing? We are just coming out of the loop and saying that to delete is equal to temp of next. Here, what we are giving? To delete is temp of next. What is making? We are making this temp of next is equal to null. It is temp of next is equal to null what we are making. Then after that, we are freeing the allocated memory for the last node, that is temp of next will be made free. After freeing that, we should assign the variable to delete with the null value. Understood? This is to delete at the end of the linked list. Now let us see how to delete a node at the middle or at the particular position. So what is the procedure we have to follow? Same procedure, we have to traverse until unless we reach the required position from where we have to delete. We have to stop previously. Then what we have to do? Say we have 4 nodes. We have, right, 4 nodes here. I want to delete this particular node. Right. What I have to do? Have to traverse here, traverse till where? Particular position -1. I have to traverse till here. What I have to make? I have to make this next position, instead of pointing this value, it should point to this value, this node. So if it is 1000, 2000, 3000 and 4000, say consider. So this what it will be having? 2000 it will be having, here will be having 3000 and here will be having 4000. Okay, so what I have to do? Temp of next should be equal to this value. That is what we are doing. What we are doing? We are traversing until unless we are going to the position. Just before the node of that position we are traversing. That's why it is given that less than, not less than or equal to. Right? Less than means it will reach to the previous node. And then what we are checking? Temp of next is equal to null. No, the condition is not true. So what I have to do? We have to increment the temp of next. Now initially we are pointing here. Now temp is pointing here. Now temp is pointing at the second node. Now to delete is equal to what we are giving? Temp of next. What is this? This is temp. What is temp of next? Temp of next is this value, that is 3000. To delete will be given with the value 3000, right? After that, what I am doing? Temp of next is equal to, I have deleted this 3000. Temp of next is equal to, I don't have any value right now here. What I am assigning? Temp of next of next. Temp of next of next. I am assigning what? Assigning the value 4000. That is 4000. Okay. And after that, I have to free the variable to delete. That is 3000 will be freed. 3000 will be freed and assign the value null. That particular memory location will be freed and assign the value as null. This is to delete the element at the middle or at the specified position. So this is what about delete operation. Next, what operation we have? We have a searching operation. How to search the particular element in the linked list. So searching is the process of finding the particular element of the linked list. So we have to follow some steps to search the thing. What is the step? We have to traverse and we have to compare the key with the current element. So step 1, traverse the list from the beginning till the end and then keep updating the temp till you reach the null point. Means till you reach the last node of the linked list. If we have to compare the key with the current data, key found, then return the value 1, and if key is not found, return the value -1. So that's what we are going to do in the search operation. Let us see the C code for searching. What we have? We have created the struct node. We have one temporary. Initially, what we have to do? We have to keep the head as it is. So we are not changing the head value. Instead, we are giving that head value to one temporary variable called temp, and this temp keep on moving. Head will be the same position and holding the same value. So why we are checking with the while condition? While condition to check whether there is element or not. If it is not equal to null, definitely there are the elements, then we can go for searching. If condition false, we have to come out of the loop and saying that there are no elements to search. Okay, so if this condition is true, then what we are doing? We are checking if temp of data at the current position, what is the data, is equal to the searching element or not. If for example, I take 3 nodes, that is 30, 40 and 50. So this is head and this is also the temp. So this is 1002. Say this is temp head values 1000, 1002, 1004, something like that. And this is null, right? So if I want check the condition, temp is equal to null at this position, temp is equal to 1000, no, temp is not equal to null, then what we have to do? Temp of data. What is temp of data? Temp of data is 30. What is a key element I am finding it for? Key element, say it is, I am finding it for 50. Whether temp of data, what is temp of data? 30 is equal to 50. No, condition not true. Then what have to do? Have to increment the temp. Have to make the temp pointer point to the next value, temp of next. Now this temp will be pointing to the temp of next. Right, now check with the same condition whether 40 is equal to 50. No, it does not return 1. So again it will increase the temp pointer, temp of next, it will move to temp of next. Now what is the data in temp of next? That is 50, right? Now I am checking 50 is equal to 50. Yes, condition true. Then it will return the value -1, saying the search element present in the linked list. This is what the C code for searching the element in the linked list. Then one more important concept in the linked list what we have is garbage collection. We call it as GC, garbage collection in the data. So what is a garbage collection? As we have seen in the many examples, while deleting the nodes from the linked list, we are deleting and we are calling the method or the function free to delete. Once we have called the function, this is a memory allocation. As we know, the linked list, we have the random memory allocation somewhere here, here, here. What exactly happens here? When we delete the nodes, it is not freed. The data will be present, but it is not accessible. That condition is called as garbage, right? Memory is full, but data is no further be used. That situation is called as garbage. What garbage collection will or collector will do, this garbage collector will collect all such memory location and freeze all the memory location at once. That is the process of garbage collector. Let us see the formal definition. Garbage collection is a dynamic technique for memory management and heap allocation. What we are managing? We are managing the memory which has been deleted from the many operations. That examines and identify the dead memory blocks before reallocating the storage for the use. It will identify dead memory. What do you mean by dead memory block? That data memory is occupied, but that data what we have in that memory is no longer useful. That is called as dead memory blocks. The garbage collections primary goal is to reduce the memory leakage. Okay, why we have to go for the garbage collection? If such things happens, as the RAM memory is very less, we don't have memory to store the recent execution values. So what we have to do, RAM has to clear up the memory. The best example what we can give is your mobile phone. On some criteria, it asks to clear the storage, right? You have one cleanup, so you press on that cleanup button, it will clean up all the unwanted data and then the files. Then it will see so much of MB or so much of KB memory is freed now. So that is a process of garbage collection, okay, or garbage collector. Garbage collection frees the programmer from having deallocated and written the object to the memory by manually. How does it do by manually? The garbage collection does not often handles the resource, rather than it only operates on the memory. What is the resource? That is a CPU scheduling, that all comes under the resource again. So garbage collection is not worried about the computer resource. It mainly focus on what? Focus on freeing the memory, not about the other resources of the computer. Then how the garbage collection technique collector works. What are the techniques it works on? When GC runs, no free storage left, and it runs periodically. When we can use this garbage collector? If there are no free memory to do the current execution, at that time we go for running the garbage collection. Or you can fix some particular time. At this particular time, I want to free the memory. After this, after 1 week or after 15 days, I want to free the memory of my system. That time also you can go for. Or free storage reaches to the threshold, or you can fix one threshold value. When the storage reaches to the threshold value, then garbage collection can be done. Okay, these are all the 3 examples or the 3 situations where we can use this garbage collector. And then garbage collection in the data structure. Most famous and commonly implemented techniques of the garbage collection, there are two techniques. One is mark and sweep and reference counting. There are two techniques we use to release the memory. One is mark and sweep, and second one is reference counting. Let us see what is mark and sweep. In the mark and sweep algorithm, as a straightforward, as its name suggests, it consists of two phases. One is mark and one is sweep. What mark phase do? What we do in the mark phase, this is sequentially visit to all the memory block. If this is my memory block, it will visit to all the memory blocks in the memory and mark all the node which has been used in the program. If some memory blocks has been used in the current running program, it will mark all those programs, and the remaining whatever the memory blocks are there, that will be collected and it will be swept off in the second phase. It will be freed in the second phase. That it will collect all the unmarked blocks of the memory and place them in the free storage area. It's very simple as that. It will check all the memory block which are in currently use, it will mark that, and remaining whichever the memory blocks are there, all the memory blocks will be freed. So that is a technique what we have in a mark and sweep. This coming what in the second type of technique, that is a reference counting. What we are doing, this reference counting is really very easy. It based on the counting how many pointer reference each allocated object. Each allocated object, how many pointer is referring to that particular object, that it will have a count. Each allocated object in the reference counting technique has a reference count field. So after counting, we have to store that count in one field. No? So that's why we have one separate field called reference counting field. The memory manager is in charge of ensuring that the reference count. Who is going to increment or the decrement that reference count? Memory manager is going to increment or the decrement that particular reference count depending on the operation what is going to happen. Object is equal to the number of direct pointers referring to then the object of all the time. Here when the reference count value reaches to the 0, then we can say that there is no garbage, all the garbage has been collected. So how to count that particular reference counting? If the reference counting value reaches 0, then it said the garbage is collected and it will be freed. Then how to calculate this reference counting? There are some steps to calculate, like object allocation, parameter passing and reference assignment. Once we have passed the object, that is when object is allocated for that particular memory, then we have a RC count as 1. When the object is allocated for that particular memory, the RC count, reference count, will be incremented by value 1. Parameter passing, RC will be incremented by 1 when the object passed into the procedure. When that memory block is passed into the procedure to execute anything, that time again we increment the RC by the value 1. Then reference assignments, when we have some assignment values, when we are assigning some values to the object, that is, for example, u is equal to v, one object is referring to the other object, the referred object goes up by 1. This is a referred object which goes up by value 1, and the old object goes the reference count value down by 1. So that's why we are incrementing or decrementing the reference count. Once the reference count reaches to the 0, we have to say that the garbage is collected. So this is all about the linked list and then the garbage collection. Thank you.